All right, so today I'm going to talk about, well, the general topic is BDD and shifting security left. I'm going to talk about kind of two ways of doing that. One is with Terraform compliance, as in the tool Terraform compliance, and one's just about general module design and some heuristics that I've found helpful for trying to look at modules and trying to help people design better modules, because that can really underpin your security model and how you actually deploy resources into the cloud. So there's two key takeaways to take from today. The first one, and this is a hill I will die on someday, but it hasn't quite got to that point yet, is that BDD is about communication. It's not about testing. And that's a common, I don't know if it's misconception or maybe it's my highly opinionated view, but having done behavior-driven development for a number of years and taught it for a few years as well now, if you start to get into testing conversations with it, people start to misconstrue the value it's providing. And I'll kind of get into a bit of what I mean by that. And secondly, modules should be deep, not wide. Now, this may be a common mental model for people. It might not. I am going to introduce it and I'll kind of point where you can learn more about it, because it applies to a lot more than just Terraform modules. So a little bit about myself. I'm Josh. I'm a principal consultant at Contino. I've been working in kind of cloud native DevOps consultancy for a number of years, AWS, GCP, trying to help, especially nowadays, regulated enterprises move. So with the last talk being about audit and talking about regulated enterprises and some of the struggles you have with that towards the end in the questions, it is a challenging space, but there are things you can do. I mean, in the past, I've worked with huge enterprises, but also tiny startups. So I'd like to think I can bring different ideas to different contexts, which is always useful. So BDD, behavior-driven development, for people who aren't used to this particular three-letter acronym amongst the thousands of others that exist in the world, generally it pairs up very well with TDD. And generally, if you're doing BDD without TDD, I think you run into some problems. But I'm going to try and get away from acronyms and try and talk a little bit more about what's involved. So what you can do with BDDs, you can take a specification. In this case, I'm going to take compliance specification because that's what we're talking about specifically here. Pull that together with some automated tests, which makes your spec executable, which is a really powerful thing to be able to do. So instead of having, a specification written in Confluence and some tests that live in GitHub, you can make them one and the same. So instead of having this mismatch and ambiguity and increased communication overhead and all these other things, that it makes things real, which is really important when it comes to these kind of specifications. Like, how does that apply to me? If people can't understand that, then you start to run into real problems. And if we think about all the kinds of people that come into these executable specifications and what it is that they try and get out of it, I mean, your security teams writing it need to be able to kind of pursue their mandate for increasing security posture across the entire company. You've got delivery teams who get this whole, you need to start being compliant to this new specification we've written, and going, but I want to get my feature done. What are you talking about? You've got your auditors who come in and want to know that you are compliant. And the whole point of compliance is it is painful and expensive if you're not. You've got platform teams who need to look at how we can make everyone compliant as a default position, not as a bolt-on. Like, I think at least nowadays, most people realize security needs to be built in. Quality has to come first. You can't just tack security on the end and go, cool, I built the thing. And lastly, product owners. They're always under pressure from different parts of the business. I generally find the better you can communicate with them about what it is you want, the higher you end up on the priority queue. If they're confused, it's hard for them to actually make things happen and to be able to understand what the impact is to their team. And when you have BDD specifications, you can start to talk very concretely about, I've got this executable test. When it's green, I'm happy. That's easy. None of this back and forth calls. I mean, we've all had enough of Zoom in the last year, and we've still at least got a few months more. So especially when you're working remotely, I think it's more important to focus on how you can make communication asynchronous, not synchronous. How can it be done simply or not at all, or over email or pull request, as opposed to constantly jumping on the phone. And generally, if you talk to engineers a lot, there's very few things they hate more than having to jump on a call because they want to be in an IDE. So if we look at what compliance tests look like in other frameworks, I picked on Sentinel for this. Not that Sentinel isn't a great tool, but this is one area where I think it could potentially be improved. And if we look at this test, what we're trying to do is you have to have mandatory tags attached to your resources. So I've spent enough of my life looking at HCL to be able to understand this. I can read through this and I can understand it. I find it hard to have confidence in everyone could read this, or maybe they could understand it, but it's going to take them a bit of time to muddle through. Because if you look through, it's like, okay, there's lists a few resource types, it lists a few tags, mandatory tags. Okay, I can get that. Uses a function to look at things, and then takes the list and runs a not filter on it to turn out a list, and then checks whether the list has more than 0 entries. Yeah, I can see how that's getting to where it is, but I can see how it's doing it, and it's a little bit harder to understand the why. What you get from Terraform compliance is you get these wonderful scenarios that are written in English. Doesn't have to be English, but I'm going to say English because that's about the only language I feel confident in saying I can speak and read. But in here, I can see that, okay, I've got a scenario outline that's saying ensure specific tags are defined. Okay, I know what it is I'm looking at now. And when I have resources that support tags, cool, that's easy to understand. Then it must have tags, makes sense. And it must contain, okay, so now there's a table with specific tags. I think this is understandable. When we go back to those 5 people, like delivery, security, auditors, platform, and product owners, I think everyone with at least a base level of understanding of cloud can understand what I'm trying to achieve here, right? And for everyone but the person writing the test in the first place, this is all they have to know. They just have to be able to understand this. They don't have to understand the how of the test. They have to understand what do I need to achieve to make this green, which is different from understanding how the test is working. So this is kind of the really cool bit. And, you know, I could do lines of code as much as that is a cursed metric to use for complexity, but I think this is just orders of magnitude simpler to understand than the full HCL spec or Golang or however you want to do it. This is just easy to understand. It's explicit. And it gets kind of better, right? Because now if I go from, you've got to have these tags, and I think if anyone's actually tried to look at tagging across a large estate, it's not so much having the right tags, it's making sure the tag values are correct as well. Like there's often a lot of tooling around, got to have these tags. Okay, cool. I mean, AWS gives you kind of native stuff that will do that. What it doesn't do is allow you to go, and these are my valid tag values. So you end up using like FinOps tools like Cloudability or Prisma from Palo Alto, or I don't know what you use. Could be Jupyter Notebooks and you're going full bespoke. But often it's about tracking it back to only specific values. Now, people will probably contend with me, and I'd argue they're probably right, that regexes are not the most readable things in the world. But if anyone has a better solution, please let me know. But on here, I'm able to easily specify not only that tags need to be defined, but what the valid values for a tag is. So for owner, have me, could have my wife. Cost code is one of the 2. Environment is one of the 3 kinds of environments we have. I haven't tried to do this in Sentinel because I think it's going to be unreadable. And I'm just going to do it like this, to be honest. And you can kind of take that to a whole bunch of different solutions as well. Like AWS config has a prior rule about tagging. Again, it allows you to tag, these tags need to be specified. Doesn't really give you the ability to go, and this is what they should be. And I know I've only picked out one example here, but the rule kind of holds that this is very understandable as opposed to, it's about the why. And the why is kind of the most important as opposed to the how. And you can kind of see if I have these kind of tests around the place, that all of a sudden things just get easier. You have easier conversations, people understand things much simpler. And that means you can all focus on delivering value, because compliance is something you have to do, not something you want to do. If that makes sense, like ideally you want to be delivering features, you just have to do compliance. So how can you make it as easy as possible is always critical. And we'll get into a bit more of making that easy with modules. But I just wanted to touch on a few BDD top tips from the years that I've been doing it, and just some common anti-patterns that are not Terraform compliance specific, they're just BDD specific as a whole. So many small tests over fewer large tests. Now, quite often looking at BDD tests around the place, what you end up is, okay, we're going to do BDD, we're going to write these scenarios, and especially if it's a team that has a history of manual testing, they will take the manual test script and they will turn it into a scenario. And then you end up with these huge tests like this. So now I have a test that's going, ensure that instances are compliant. So it's got to do tags, it's got to have an instance profile. The instance profile should have admin permissions, should be an approved machine type, should be an approved AMI. Now, when this test fails, do I know why? Instantly? No, I can probably figure my way out looking at the error messages, but it's the same. You shouldn't be ditching the same rules of thumb you have for unit tests, right? Like unit tests have one assertion. That's generally a pretty good rule to follow in BDD as well. Like if that test fails, I should be able to read it and know exactly why it failed. Shouldn't really have to look at the stack output or the stack trace or anything else there to understand. It should be, oh, that test failed, that means this. Again, it's all about those quick feedback loops and clarifying intent, rather than having to dig into the detail every single time. I also said writing scenarios is cross-functional activity. I really do not think that you should be writing BDD tests alone. The general best way I've found doing this is with having a product owner. That could be a security product owner, whoever is the product owner for the team you currently have, and having 2 engineers with them, the so-called 3 amigos. Although 3 amigos technically had engineer and tester, but my opinions are shining through here, and I've got 2 engineers because I don't like having delineation between engineers and testers in my teams, because I think it promotes the wrong kind of culture. But what this allows you to do is have a very quick feedback loop with the product owner, like who's deciding what the right thing to build is? That's the product owner. So you need to have them in the conversation. And then you have 2 engineers who are about building the thing right. They can talk to each other, they can have a conversation, because 2 heads are better than 1. I think that pairing has kind of come forward as a core activity. I mean, we're talking going back to XP initial days of kind of pairing and becoming more mainstream. But generally, having 2 people to look at something, you'll end up with a far better outcome than 1 person. It stops people getting rabbit holed. And also the wonderful thing is you have this conversation, 1 person's sick, away, on holiday, there's someone else who was there as well. So instead of having this single person dependency all the time, you're building in redundancy within the team, which is always a wonderful thing, because a single person dependency is an awful thing to have. And the last one was using it as a gate for PRs. Now, this is a very lightweight way of doing it, which I like, because you can just go and implement this in about 20 minutes. There's no point trying to build out some giant CI/CD pipeline with all this complexity in it. Like, just go for what you need. And I think there's an adage of no one cares how cool your CI/CD pipeline is. Yeah, that kind of, well, maybe some people do. Maybe the people who listen to these kind of calls do, but generally people don't care. But if you can hold all your compliance tests centrally and build them into every single CI/CD pipeline, it gets very easy to start getting compliant infrastructure, and only compliant infrastructure happening in your environment. Now, I've only really talked to prevent here. Like, when I think about compliance, I think about it in 3 different stages. You've got preventing, you've got detecting, you've got remediating. Obviously, this tooling only talks to prevention. You can't run these tests against live infrastructure. You can only run it against, in this case, Terraform plan. But at least if you've got prevention in place, you're not getting worse. And that's also a very good place to be. For detection remediation, I kind of last week wrote a fairly substantial article on this, which will be linked in the slides, which will be linked afterwards, that you can go and read. And it kind of talks about what other strategies exist. They get a little bit more cloud specific at that point for live infrastructure than just plans, and especially for remediation, but there's kind of some more detail there. And also in the slides, I have linked to Terraform compliance as well. Go have a look. I think even if you decide not to use it, it will probably challenge you in some good ways. And for all things BDD, Cucumber is probably the best place to go as well for more explanation of how to run workshops and just how to do BDD as a process, because it is something that you can use almost everywhere, and I'd argue probably should be using pretty much everywhere. So on to topic 2, module design. So the wonderful thing about modules is, well, one of them is they enable secure by default. Now, I don't know about anyone else on the call, but if someone asked me to write a KMS policy from scratch, it's going to take me a long time. and or be awful. So really, like with the KMS key, can I get someone to just define what that least privilege looks like once for my use case, and now I don't have to think about it anymore? It's wonderful, right? If like the best KMS, the easiest KMS policy to write is one that's already written for me that I know is correct. I think it's always critical to think about product market fit for modules. Like when you're releasing modules, even internally, not like public out to the whole world, but internally within the company, is you want to achieve product market fit. And what I mean by that is you want people to be pulling modules without you having to push modules on people. Like normally when you start off with this thing, you're like, oh, we really want you to use modules, it'll help and all that kind of stuff. What you'll find is you mature the process, they start to be pulled from you. Like it's word of mouth, and other teams tell other teams to use modules because they've got these wonderful things happening. And people start contributing back to a central module repository and stuff starts getting better. It's not the platform team's job to produce all the modules. Because the platform team doesn't understand every use case. It's more about having this ecosystem around modules, and you'll find that will naturally start to build upon itself if you've achieved product market fit. Like you can go read Lean Startup on this, the kind of classic Eric Ries book from quite a while ago now, which talks about how they kind of build loops in to iterate towards product market fit. And when you're thinking about producing modules, you should be thinking about your audience. Like why are they wanting to use them? And I like to think of developers as lightning. Sometimes they always want the path of least resistance. They want the quickest way to get from A to B because that allows them to do the feature. They don't want to be generally deep in HCL for long. They want to be delivering business value and tackling interesting technical problems, and making sure an S3 bucket, for example, has SSE enabled. It's not an interesting problem. So how can you optimize for the least resistance in your modules? And I think this is something that I've seen teams misstep on slightly or have issues with. And the way to think about it that I found most beneficial is modules are an abstraction. And we use abstractions everywhere, all the time. Same as BDD is an abstraction over the testing, modules are an abstraction over the resources underneath. And when you think about abstractions, a good abstraction reduces cognitive load. It reduces the amount I have to think. And I quite like not having to think really hard all the time. I mean, there's the old parable about if you're it's twice as hard to debug something as to create it in the first place. So if you're being as smart as you can possibly be when you write it, it's physically impossible for you to debug it anymore. So a good module and a good abstraction reduces cognitive load. Now, this brings me to kind of the deep wide models that I referenced at the start. So when you have an abstraction, you kind of have two options, or there's kind of two ways of looking at it. You've got deep modules and you've got wide modules. And what the delineation really is that bit in green is how much I need to understand to use it. And ideally, I want to understand as little as possible, right? And you can see here with the deep module, it's smaller than the wide module because a deep module has hidden more things under the surface. It's hidden more of it under the surface. And that's the crucial bit about reducing that cognitive load, because now I only need to understand that top piece. And that's where this resistance comes in. Like the more I have to understand, the more I have to learn to be able to use it, the more resistance I'm going to feel from using it in the first place. And I think the easy way to understand what this green section is in the Terraform module is the variables. They are your public interface out to your consumer. You expose certain variables, and that is how much they should have to understand to be able to use the module. And to just put some numbers to this, because I just can't help myself, I always have to put numbers to things. When you have 5 variables that are binary, so true, false, 5 variables, true, false. By the time you have 5 variables in place, you have 32 different permutations of true and false you could possibly have. That's 32 different states you have to account for. Some of them will be invalid, some of them will be true, some of them might have bugs. If you, instead of having 2 options, you have 5 options, 3,125 permutations. Yeah, I don't know how you possibly test this, or I'm sure it's robust. I mean, I think there was a discussion on Reddit the other day about the general AWS VPC module that's publicly available, and I think it had 400 parameters. Yeah. At that point, how much, I mean, there's probably good defaults in there which help reduce this, but at the same point, like how much value am I getting from using the modules of doing the resources myself? And that's generally why I think people always tend towards writing their own modules rather than consuming from the wider public, right? Like, I really think the number of variables is a heuristic for module quality. Those people who have had the unfortunate case of suffering to work with me know that whenever they write a new module, I will start picking at their variables instantly off the PR. I'll go like, do we need this? Do we need that? If we've got a default here, like, are people actually ever going to override that default? Or is that default something we can just embed in locals and not have to worry about anymore? And I think it's a really easy, quick way to challenge the module design rather than getting into the nuts and bolts of how it's achieving things. How well have you understood the problem space that you've come up with a elegant solution? And one of the other cardinal sins of abstractions is premature abstractions are the root of all evil. And what I find challenging is people like to write modules for tomorrow's problem, not today's problem. So they'll extend this public interface because like, oh, someone might want to do this. Has anyone asked to do this yet? No, and don't put it in. Because at the end of the day, changing a public interface is really hard to do. Removing from a public interface is 100 to 1,000 times harder than adding to a public interface. So you should always optimize for what's going to be harder. And that removing things is really, really hard because what about all the people that currently use that? How are you going to manage that? How are you going to get them to upgrade? Are they going to stop upgrading because now it's too hard to move? There's all these different things, which makes it a lot harder. And again, builds that resistance factor. If your public interfaces keep changing and you introduce breaking change after breaking change after breaking change, people are going to go, well, I'm not moving anymore, or I'm going to do it myself because it's no less effort for me to use the module. And instead you're breaking me randomly. So if anything, this is actually not just zero value, it's negative value from this. So like, it's always easy to add things, very hard to take things away. So optimize for not having to take things away, not adding things. And just kind of a little bit of a thought here, and I don't have time to go into them in any more detail, but like, how else can you reduce resistance? If you're trying to embed modules, trying to get it so people have got all these secure defaults in place because your modules are doing sensible things, what other sources of resistance are there from people really embracing them and leveraging them? Documentation, the classic, like, and it generally doesn't get written. Obviously, there's great tools like Terraform docs, which allow you to start automatically generating stuff, but also examples and, building out robust documentation is one thing HashiCorp is amazing at, is doing really robust documentation for things. And there's a good reason for that. It really helps adoption and engagement of things if the documentation is good. Don't make people learn everything you had to be able to use it. Like, you're not doing them a favor at that point. Another one is investing into teams. Be willing to invest time and effort into them to get people to use it, especially at the start with a new module. Go sit with them, see how they feel, get that feedback loop in place so you can understand any design choices you would have made different. And the last one is commit fully. People generally underestimate the ongoing maintenance cost of producing these kind of publicly consumable pieces. You don't want people to start to believe that you're just going, all these modules you produce are going to be abandonware 2 months after you build them. If you're going to do it, you have to be willing to accept the maintenance burden for an extended period of time. And this isn't the next 2 weeks. It's not the next 2 months. It's probably like, will I still want to be maintaining this in a year? Is that still going to be part of what the team is going to want to do? If so, it's probably good to start producing these things. If it's going to be, we're not sure yet, then don't release that out to the world. Look at how you can de-risk that and not get a reputation for abandonware. There's a really good law that came out of Google called Hiram's Law, which is about at some point with enough users, every possible combination of your code will have been used. All observable behaviors, whether public documented or planned or expected or not, will be relied upon by someone, which kind of comes into that whole, it's really hard to take back. So the software engineering book at Google, it's a bit of, you probably don't want to take everything, but it's good to just understand, and it's quite challenging in a lot of the ideas it has. And on this deep versus wide module piece, philosophy of software design was, I think, the first place to coin that kind of mental model. But reading that, it's a pretty short read. You'd do it in probably an evening. Well worth it from someone who spent a lot of time trying to teach people how to write good software. And at the end of the day, that is what we're writing with Terraform modules. It is software, really. So just to leave it on here, BDD is about communication, and modules should be deep, not wide.